Hey everyone, it's Mr. Canfield. Today we're going to look at the Chapter 7, not topic assessment, topic review. Oh, we do the same thing every year, or every chapter, right? Okay, so I'm going to go through these questions pretty quickly, but if there is work to show, I'll show that work. And just remember, the key thing is we are trying to get the main ideas and make sure that we understand them and can do them ourselves, not just can I watch somebody else do this. So if you are watching a problem and then copying me after I do it, you're not really helping yourself. What you need to do is you watch like the start, and as soon as you think you can do something, you pause me, you do it, and then you come back and see if we match up. Because again, otherwise you can think you know what you're doing and really just waste your time because all you're doing is mimicking instead of figuring stuff out. So, okay, let's go. For a dilation with a scale factor less than 1, how do the angles and side lengths of the pre-image relate to the angles and sides of the image? So I see pre-image, that means before, and image means current. So I guess like that's the original, that's the new. Well, dilations, they don't change angles. So I know I gotta have angles are congruent. So I know I need one of these two. And it says the scale factor is less than 1. That means we're multiplying by something less than 1. So it's shrinking down. So that means the side lengths would be smaller. Oh wait, the pre-image. So it's asking, is the pre-image bigger or smaller than the new one? So the new one is gonna be smaller, so that means the pre-image is gonna be bigger. Right, it says pre-image. How does the pre-image look compared to the, yeah, so trickily worded, that's what I got. All right, 2, what is the scale factor of the dilation shown? So they're telling me a dilation, that means it is guaranteed these are similar. So I don't need to go and do lots of work figuring out like, hey, are these similar triangles or anything? I'm guaranteed. All I need to do is go, okay, well, I'm doing, let me just reset this really quick. So I take 8 times something, and that gets me 12, right? 8 times, I don't know, and that gets me 12. So if 8 times my scale factor is equal to 12. Well, then I just take 12 divided by 8, and that'll give me my scale factor. New divided by old. And 1.5, which all you gotta do is do math, enter. All right, you push the math button. That first option to fraction, enter. So 3/2. Notice they have 3/2 and they have 2/3. If you do it the wrong way, if you do 8 divided by 12, it gives you 2/3. The way that we're doing it, we're dividing where we end up by what we started with. And that's how we get from 8 to 12. So if I do 8 times 3/2, that gets me 12. That's what scale factor means. That's why we're dividing the way that we did. All right, what are the coordinates of the image D.524? So this is just saying dilate by 0.5. You just take each of these times 0.5. 2 times 0.5 is 1. 4 times 0.5 is 2. Done. All right. 4 says graph D2 of triangle XYZ. So there are kind of 2 ways to do this. One of those is to dilate the directions by 2. Another one is to dilate the actual numbers by 2. So here's what I mean. If I look at x, how did I get to x? Well, I could say that for x, I go up 2/1. So for dilation 2, I take each of those directions times 2. So instead of going up 2/1, I can go up 2/1 and then do it again, up 2/1 again, and get my new point. Or up 4/2. Another way to handle this is to look at that point. That point is literally -1, 2. And so if I do each of those times 2, I'll get -2 and 4, which is that point right there. So either way, it works out. For this one, for y, like it's 2, 1, so it'd be 4, 2. Another way, I see it's like this double block box, so I'm just gonna go double block box, boom, get my new one, right? Because I'm just doing times 2. If it had been times 3, I would do double block box, or I would just do 3 of them. And then this one is -1, comma, -2. So that's gonna go to -2, -4. And then we do have to connect the dots. You don't need to use a ruler. Yeah. All right. 5. Nope. 5. Which best describes the composition of transformations that maps LMN to L prime, M prime, N prime? Okay, let's look. So here's the new one, here's the original one. So the 4 things I see here are dilation by 2, dilation by 1/2, dilation, so I see that. Let's look really quick. This is our original, here's the new one. So the new one is bigger than the original, so I know I'm dilating by 2. So I already know it can't be B and it can't be D because those are dilation by 1/2. The next part I gotta figure out is like, oh wait, is this rotated at all? No, it's not rotated, so I know it's not gonna be any rotations. Oh, wait, it's A. Cool, I'm done. Let me just double check though. So if I'm dilating it by 2, that means we're multiplying, you know, each one by 2. So like that one goes there, that one goes there, and that one goes there. And then it says, so that's the first thing that happens, right? Because this notation, it's always backwards. Like you do this is last, and then each one after it is the next last thing that happens. So that's the first thing, and that's the last thing. So I blow up by 2, and then I go over 1, and then 1, 2, 3 up, which is exactly what it says. All right, so cool. So that's how I'd figure out number 5. Number 6, what are the coordinates of U prime for the transformation of this for this? And so, so all I'm focusing on is U, okay? And it says do a D4 and then do a T that. So I'll do D4 first. So D4 is take -8 times 4, which is -32, and 3 times 4 is 12. And then it says translate it -3, comma 1. So you just literally subtract 3, add 1. So -32 minus 3 is -35. And then 12 plus 1 is 13. So that would be U prime. And so what I'm going to say now is you should try for yourself if you kind of watch me do that. What about V prime? What is V prime? So I'll give you a second. Try it. If you tried V prime, I got so it's 8 and then 5. So 5, and that's 4, and then 5. 5, 5 is what I got for V prime. Okay. So let me know if you have any questions about that. All right, let's keep going. 7. Label each statement true or false, a similarity transformation that maps one circle onto another must include a reflection. So a way to get one circle to another circle, you always have to have some kind of reflection. Reflection, remember, it's like flipping it like this. If you start with a circle and you end with another circle, no, you don't need to flip it at all. There is no similarity transformation that will map one circle onto another. That is not true. It's easy. You just take a circle and you dilate it, and you move it. And that's all you ever have to do. You just blow it up and move it around, or shrink it and move it around. All circles are similar. This is true because their shape remains the same. It's just the size of it, the size of the sides, even though there's not really sides. It's a curve, but okay. bottom one says, given STU and DEF, what is the measure of angle D? So we're trying to find this one. Well, let's see. If I'm looking at my triangle here, it says STU DEF. That means that D is similar to S. So it's the same angle as angle S. Oh, we know S is 29, so we know D is 29. If it had asked for angle F, that'd be a little bit more challenging. No, wait, we know that one, sorry. If it had asked for E, that would be a little bit more challenging because E and T match. We don't know E or T, but we do know 29 and 46 are the other two angles. So like we'd go, oh, okay, that's 46, that's 29, and we could subtract them from 180 to find T. All right. Next. Given these two triangles are similar, what has to be true? Let's see. If I take, we've never done similarity stuff. We've never done proportions with angles, so I don't think it's going to be this one. We have done proportions with sides, so I think it's going to be this one, or it's potentially this one. Let's see. Angle N and angle T, oh, they are in the same spot, so yep. Ones in the same spot have to be equal. And then MN is equal to ST. Well, we're not guaranteed that sides are equal to each other at all in similar triangles. And then let's look at this one. It says LM, so it's the first two, and then LM is to RT, and then LN is to RS. So they got this backwards. They should have done LM and RS together, and then they should have done LN and RT together. So let me just make sure that if this was LM RST. So it's like 1, 2, 3, 4, 5, 6. So I'm just kind of, so that's like saying 1 and then RT is 6. That's like, so this one and this one. And then that's supposed to be the same as 3 to 4. And then that's this one to this one. Yeah, we're flip-flopping. We're not supposed to take pieces to the not corresponding side. We're always supposed to take them to the corresponding side. So this actually, I'm going to say, is probably not true too. And I'm going to pause for just a minute. I realize I don't have my answers. I don't have the book answers up. It's just me by myself, and it's so easy to over or underthink something and get the wrong answer. And I'd rather make sure that I am telling you the correct answers for these. So just pause for a minute. This is where a better video editor would go in and have like background music while I'm fumbling around finding this. All right, let me just make sure. Oh, okay. I'm wrong. Let's look at this first one here. If I look at the, oh my gosh, I just wasn't thinking enough about this. Let's see. The ones I crossed out, I was right, and then I left this one. I hadn't gone to this one. I was about to cross it out though, but let's look. What's the measure of angle L and then the measure of angle R? They're both the first angle, right? And then what about the measure of angle M and the measure of angle S? They're both the second angle. So this is the same both times. This is actually equal to 1. It's because those angles are equal. So this is equal to 1 and this is equal to 1. This is a tricky one. That's a tricky one. That would definitely be in the bonus category for me. It wasn't something we talked a lot about. All right, 10. Which condition would prove DEF is similar to JKL? So let's see. We have DE is 14, and we have JK is 7. So that is the first two for both of those. That means that to get from DE to JK, we had to divide by 2, which they are going to show probably as a 2-to-1 ratio. Like this is twice as big as that. That's so twice as big as that. We haven't used a lot of ratios like that, but that's what that's saying. This is 2, that's 1. So then to show that the two triangles are similar, it looks like we have side angle. Looks like we need this guy and this guy to match up with each other. So that's what, DF and JL. So that'd be DF and JL. And we want DF to be double what JL is. So we don't want JL to be double what DF is. That's why it's not this one. All right, onward and upward. 11. We have these triangles. We want VW. So remember, we have, like when we have these parallel lines like this, we have a situation where we can do like piece over piece is equal to piece over piece. You know, or 55 over that is equal to 72 over that. And you're like, but we don't know either of these. Well, hold on. We know the whole thing's 88 here. What's 88 minus 55? 33. That's this part here, right? And we want VW. So can't we just say x over 33 is equal to 72 over 55? Oh, I did the wrong setup, didn't I? If you remember, I showed you that this still does wind up working, but I'm supposed to do what? 33 over 55 is equal to x over 72. Either way, though, we're doing 33 times 72. This is just like the more official way. But like I said, either one does work. So I'll do 33 times 72. I'll get a monster number, 2376, and then that's equal to 55x. So I'll divide that by 55. And if I want to look smart, I'm going to, instead of writing 43.2, I'm going to write math, enter. Well, this is 216 over 5. So 43.2 or 216 over 5. Ooh, fancy me. All right. Let's keep going. This one says, what is JL? JL. Oh, wow, it asks for the entire side here. Well, I'm not going to find the entire side right now. I instead am going to find this piece right here, because we have a really good setup for this. Whenever we've got a right triangle and it drops in altitude like that, that lets us do the geometric mean thing, where we do 8 over 6. 8 over 6 is equal to 6 over y. That setup will always work. And now cross multiplying this guy is easy. I can say 8y is equal to 6 is 36. And then divide by 8. So 36 over 8. I don't think that goes in nicely. Yeah, so y is 4.5. But here's the thing. It wants to know what JL is. So notice how they list 4.5 as an answer. It's a trick, right? They're trapping me. If I got y is 4.5, done. Nope. I already do 4.5 and add it to the 8 that we have there, and we get 12.5. All right. So now it asks me for BD. This one is straight up easier than the previous question. We do 8 times, we do 8 over x is equal to x over 2, right? So 8 times 2 is 16. We get x squared. Take the square root of both sides. We get x is equal to 4. Right? 8 times 2, square root 16. Done. All right. I know I'm kind of flying through this. I got to cover a class soon, so I'm just trying to get it done, trying to be thorough at the same time, just getting through everything. Okay. Which are similar to MKL? Okay, I gotta be super careful with this. So MKL. All right, so K is, that's my 90 degrees. So the first thing I like to do with these, if I'm trying to check them off, I go, okay, do any of these not, is that middle not actually the right angle for them? Because if it's not the right angle for them, then I know that it can't be similar to MKL. So like LKJ, okay. This is still possible, but then LMK, M is not a right angle in the middle, so I already know it can't be that one. MLJ, MLJ. Okay, so this one could be, but since that wasn't a right angle in the middle, boom, I'm already good. The next one is angle M is like chilling off here on its own, so like I'm guaranteed that that's angle M, like with a single guy there. J would have a double guy here. And then the way that it breaks down, since that's single, this will be double, and that'll be single. Right, like they have the angle that they don't already have that's left over. So, so M is my single, L is my double. So if I'm looking at LKJ, LKJ is going to be double 90 single. Oh, that's not the right order. So LKJ is going to be a no. And, oh, wait a minute. Why am I wrong? Shoot. It says I'm wrong. It says that one is similar. Uh-oh. Hold on. What am I missing? What am I missing? MKL. Oh, I made it such a silly. All right. Wow, okay. Look at LKJ. I was underthinking this. Look at LKJ. Here's LKJ, right? Well, LKJ has a single and then a double. Angle L here is a single, K is a 90, J is the double. So it is following that order, yes. And then let's look at MLJ. So MLJ is this guy here, MLJ. MLJ, and then if I look at my diagram here, at M, I've got my single, at L, I've got my 90, and at J, I've got my double. So I'm good. That one does work. So my mistake, in case you missed it, so I looked at angle L. There are two different angles at angle L. What I was supposed to do was think about the triangle LKJ on its own and not just pick one of the two. Because one of them is going to be my single, one of them is my double. And I blanked and didn't do that. So learn from my mistake. All right, next one. What is the value of x? So remember we got those parallel line situations? I'm gonna do 2x minus 8 over 5 is equal to x minus 3 over 3, and it's just algebra. So I'm gonna be careful. I'm gonna show all my steps really carefully. In class, you know, I don't really do these that much anymore because if all you're doing is waiting for me to do this for you, you're never gonna be able to be successful in this. You have to start trying these. So it's the truth. So if you've been getting stuck on these, if that first step is awesome, great. If the setup is like what it's really asking us about here. 2x over 5, x minus 3 over 3. Because that's what it was called, the side splitter theorem. You don't need to remember that name, but. So, and then I cross multiply. And when I do that, I have to distribute this 3 to both of those. So like 3 times 2 is 6, so it's 6x. And 3 times 8 is 24, but since it's a negative, I really want to think about this like it's saying 3 times negative 8. So it's actually minus 24 there. And then this same deal, 5 times x is 5x, and 5 times 3 is 15, but it's negative, so minus 15, and we're here. Now I've got x's on both sides, so what I need to do is get rid of one of the x's by subtracting or adding it, doing the opposite of what it is. So I look at this, it's positive 5x, so I'm going to subtract 5x and then subtract 5x from from its like term. We do that. We're left with a negative 15 on this side, and a 6 minus 5 is 1, so 1x minus 24. Remember that 1x is the same as just writing x. So this is x minus 24 is equal to negative 15. X minus 24 is equal to negative 15, so I'm going to add 24 to both sides to get x by itself. We get x is equal to, I think that's 9, but I struggle with 9s and 11s, and so if this was 25 and 14, it'd be 11, or 25 and 14 it'd be 11, and I just mix them up all the time, so it's good for me to double check. So I got x is equal to 9. That is one of the answers. It happens to be the correct answer. All right. Now we look at this diagram. It says, which conclusion does the diagram support? Okay, let's see. So that's where we can do things like 1 goes to 2 is the same as 3 goes to 4. So if I look, AB is 1, BC is 2. So that was 1, that was 2. FE was 3, ED was 4. Yep, so that is true. AF is equal to half of CD. AF is equal to half of CD. Well, wait, that's saying that AF is smaller than CD. It's bigger. But we don't know. There's not enough markings on here to say exactly how the sides are related to each other. Let's look at this one. BE to CD. So BE to CD, that's this one and this one. Is that the same as AF to BE? We don't know that. If we had done BE to CD, we could have done like this piece to if there was a piece up here or something, but no, there's not enough there. And then BE is equal to half of CD. No, it's not half as big as that. It's also no way to know exactly what it is. All right, what is EF? All right, so we see our angle bisector here, and the way this is set up, hopefully that reminds you can do x over x plus 10 is equal to 24 over 54. The other way people like to set this one up is they'll do x over 24 is equal to x plus 10 over 54. And remember, the way that proportions work, it won't matter. Both ways that works out for you. So now I can just go ahead and solve it. So I'll do x times 54 and get 54x, and then I'll do 24 times x plus 10, and be very careful. You got to distribute it to both of them. And I'll get 24x plus 240. And now I'll subtract the 24x from both sides. And let's see, 54 minus 24 is 30. So 30x is equal to 240. I'll divide both sides by 30. And I will get x is equal to 24 over 3, which is 8. All right, final round. So our final question. I can do this again. Anyway, so if you wanted, you could do 14 over 4 is equal to x over 7. Doesn't matter. So 7 times 14 is 70 plus 28, so 98. So 98 is equal to 4x, and I'll divide both sides by 4. So 98, what, 49? So 49 divided by 2 is 24 and a half. So 98 divided by 4, 24 and a half. All right, x is equal to 24.5. All right, so I don't 100% get why they give a harder question before the easier question. I think that's a mistake, but I hope this was helpful. And yeah, good luck on your test. Bye.